Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue our new mini-series based on our new must-have Web Handling Handbook. We will continue our wrinkling theme from the last 3 weeks. In this clip, we will show several ways to quantify wrinkles. These tools will supplement visual troubleshooting given previously and take your trials and DOEs to the next level of determinative. I know your time is precious, so let's get started. Wrinkling is one of the top causes of waste, delay, and customer complaint. As such, the objective function deserves some attention so that you get the most from your analysis and troubleshooting efforts. A good measure of wrinkle severity will improve the resolution of our design of experiments or other trials. A good measure will improve the statistical trustworthiness of the resulting conclusion. Also, trial times might be made shorter, even while improving the resolution so that you can reduce lost production. In summary, a good measure will help you know better, faster, and cheaper if you are really making progress against wrinkles. So, what about waste or customer complaints? While these are currently the most common measures of wrinkling severity, these measures have many truly debilitating handicaps, often rendering them worse than worthless for the troubleshooter. First, as we've learned time and time again, a wrinkle is not a wrinkle is not a wrinkle. There are perhaps 20 common but totally different types of wrinkling, as we just learned in Web50111d, each with a distinctly different remedy list. Throwing several different types of wrinkles from several different sources on the machine means that the strength and resolution of every single factor we study will be diluted. Using customer complaints as a measure of severity is even far, far worse. It suffers from all of the above problems, plus several even worse ones. First, the results will be delayed by weeks or months compared to internal rejections. Second, the customer's own process adds staggering amounts of noise to the study. Third, the customer sometimes or even often does not attribute the correct cause to their complaint. Finally, if that were not enough troubles, your customer's threshold of pain will vary every hour of every day with every change of grade on their end and every person evaluating the wrinkles, and finally will vary between customers. Some customers, typically the smaller ones, will take anything, while others will complain about the smallest thing, even if it's not your own fault. Clearly, as good troubleshooters, we need a much, much better measure of severity than customer returns, which could be worse than worthless because it can waste everyone's time and money and patience and get no answers at all, or even worse, the wrong answers. After having said all of that, in theory, we could use waste as a metric, provided that we filter on one and only one single wrinkle type, and that one and only one source location. Very few waste accounting systems have this resolution, and very few waste accounting systems can be upgraded, either temporarily or permanent, to have this finer resolution. More pragmatically, using money or weight or length seldom adds extra utility. Instead, I will propose 3 measures that are mechanics-based instead of money-based. In short, they are far closer to the root cause mechanics than money is. These measures include severity as a count, severity as an angle, and severity as excess width. All can be set up very quickly and taken down just as quickly if you wish. All have an extremely fine resolution. One of the simplest and most general of the measures of severity is simply to count the wrinkles crossing some target roller, as seen in Figure 9.1, taken from our must-have 750-page Web Handling Handbook. There we teach 3 levels of increasing severity. At the least severe level, we have only troughs in the open web span. Then wrinkles crossing rollers, which are usually the level of rejection for most webs, and finally, creases being worse yet. There are mechanics-based reasons that we won't explain here, but is well explained in the book, why count is so very determining. That is, wrinkles tend to be binary. In other words, they either cross the roller or they don't. Instead of there being big wrinkles and little wrinkles and medium-sized wrinkles in between big and little. Obviously, then, 1 wrinkle is better than 2, and 0 would even be better yet. This measure is even more powerful because fractional wrinkles can be used when reliability is more typical of most plants. While it is seldom possible to have a 0.1 sized wrinkle, you could have a 1-sized wrinkle crossing the roller 10% of the time. While it is seldom possible to sustain a 0.01 sized wrinkle, you could have a 1-sized wrinkle crossing a roller 1 meter in 100 meters of length. Well, you get the idea. What this fractional severity of wrinkles allows you to do is to show progress, even when wrinkles persist. For example, a customer might reject a roll with only 1 wrinkle as surely as a roll with 100 wrinkles. Yet clearly the former is much improved. As I teach in my Web 101 class, some wrinkles are stubborn enough that they require 2 factors or maybe more to be manipulated on some fussy process to satisfy a fussy customer or manager. The 2-factor solution would be extremely difficult to uncover using the more traditional measures of waste or customer complaints. We will not discuss here the many other useful techniques for counting wrinkles because that is covered in more detail in our book as well as elsewhere. As we introduced in Web 50111b, and as covered in much more detail elsewhere, the wrinkle at an angle, otherwise known as the diagonal shear wrinkle, is one of the most common of the major cases. As it turns out, the angle of the wrinkle is a direct measure of the mechanics-based severity. The reasons have to do with more circle analysis and will not be detailed here. All you have to know is that 5 degrees is better than 10 degrees, and so on. Pretty simple to see or measure, and pretty intuitive. All we need to know is that if we do something that reduces the wrinkle angle, we are getting closer to a complete solution. Of course, just as in the severity as a count from the last slide, we can show progress, even when wrinkles persist. Again, we will take it. As I teach in my industrial problem-solving class, the home run thinking is a major pitfall to progress. So, let me give you just one practical example for using angle as a measure of severity. You can sometimes align rollers to correct an in-plane roller misalignment wrinkle, a most common subcase of the diagonal shear wrinkle major case. merely by trial and error moves and noting the wrinkle angle. So, the wrinkle begins at a high angle. We bump the idler roller in the direction taught elsewhere. The wrinkle gets less. We bump it a second time in the same direction, and the angle gets even smaller. And finally, we bump it a third time, and that clears the wrinkle. However, as I teach in Web 101 and in my industrial problem solving classes, we don't stop there. We continue bumping the roller in the same direction until the wrinkle just starts to appear in the other direction. The range of misalignment is from the onset of wrinkling in one direction to the onset of wrinkling in the other direction. Of course, we would put the roller in the middle of that range for maximum wrinkle resistance. We will introduce just one last measure here. This one is similar to count. It makes use of the mechanics principle that for a given roller and web, the height of the wrinkle tends to be the same. Here we simply sum the number of wrinkles times the height of the wrinkle times a factor that is given in our book, along with the techniques and tools to do those two measurements. I can't take credit for this because those tools were developed largely by one of my brilliant co-authors, Dr. Dilwyn Jones. For those of you who are interested in the latest wrinkling maths, modeling, and research, he has a couple of dozen pages just for you at the end of the chapter. However, not only is this strain-based technique useful for quantifying wrinkle severity, particularly any of those in the MD major case, it can also be used for quantifying bagginess. The only major difference is that case you would be measuring excess length instead of excess width. Again, this third measure can show that you are making progress even when wrinkles still persist. Again, making your wrinkle trials and conclusions better, faster, and cheaper. We hope you have enjoyed this introduction to measurements of wrinkle severity. We hope that these inspire, if not help you, in your wrinkle reduction efforts. Obviously, we can't cover the large area of wrinkling in this short clip, nor do we need to, because wrinkling is one of the best documented areas of web handling. There are more than 200 articles, columns, papers, theses, etc. that you can find using the free and easy Roysum Library search tool by APITTA. However, let me suggest a far faster and easier way. You will find most everything you need to know in 2 hours on wrinkling, with another 1.5 hours on the subject of spreading, in my award-winning and trademarked Web 101 school that has been taken by 5,000 students just like you. It is available in your plant, in public venues, as well as video on demand through AIMCAL, APITTA, and TAPPI. Finally, that and much, much more can be found in 100 pages in the Web Handling Handbook. However, don't be intimidated because each chapter begins at the most basic level, something that a lead operator should be able to easily follow, and then proceeds in steps to the latest research on the subject. Thank you so very much for joining me in this mini-series showcasing some of the crown jewels of our new book. Stay tuned for the next clip where we will continue our tour of our new book with an introduction to spreading. If you have a topic you would like to hear about, let me know in the comments section below. If you found anything interesting or useful here, Please like and share with a colleague, supplier, or customer who is struggling unnecessarily with wrinkles. See you next time.